Good day, learners. For today, you will learn about Lesson 5 Projectile Motion. For this lesson, you will deduce the consequences of the independence of vertical and horizontal components of projectile motion, calculate range, time of flight, and maximum heights of projectiles. To begin, let us analyze this one. You throw a football horizontally and drop a football from the same height and at the same time. Question: which will hit the ground first? Before you answer that question, let us know about projectile. Projectile is an object with independent vertical expressed in y-axis and horizontal expressed in x-axis motions that moves through the air only under the influence of gravity after an initial thrust. We also need to consider these two. We have there the parabola and the trajectory. To begin, a parabola is the name given to the shape of the curve a projectile follows when gravity is the only force acting on it. It is shown on this GIF. Now, while trajectory is the parabolic path of a projectile. Now, what are the forces applied in projectile motion? There are two major forces that are applied into it, which is a resistance and the gravity. Always remember that depending on the shape and density of an object, it is often possible to ignore the effects of air resistance. Therefore, in most of the circumstances, air resistance is not considered. This reduces the forces on the object to one constant force in a constant direction, giving constant horizontal velocity and constant vertical acceleration. Always remember that these two has been discussed in the previous lesson of motion and also in kinematics. With all the above statements, we could consider that horizontal motion is therefore very simple and vertical motion can be solved with the constant acceleration equations. And able for you to understand it more, let us consider the x and y axis. X axis and y axis velocity act independent of each other. What does this mean in the projectile motion? It means that the acceleration due to gravity only affects the y axis motion, as gravity is only concerned with the y axis. And no matter the velocity in the x axis, the y axis is doing something different. Therefore, in solving projectile motion, x axis and y axis are independent of each other. To talk first about these axes, we have there the x axis. In x axis velocity, x axis motion is not affected by the acceleration due to gravity because, as mentioned earlier, it will not be dependent to gravity. Now, x axis motion is at a constant velocity. The constant velocity can be expressed commonly depicted as the JF is concerned on the right side. As you can see, the point 1 to point 2 and point 2 to point 3 almost have the same equal spacing, representing that there is the same displacement per time. Now, talking about the y-axis velocity, y-axis motion is affected by the acceleration due to gravity because, as being mentioned, gravity is affecting the y-axis or the vertical motion of an object. Now, always remember that we need to consider that in y-axis motion, it is accelerated at 9.8 meter per second squared down, which is also the acceleration by gravity value. Now, always remember that it slows down on the way up and speeds up on the way down, as it is being affected by the variable being mentioned. Now, combining the two, the x and y axis velocity, we could create and follow an upside down U shape, or again, we call that as a parabola. Now, let us express this one into quantity so that you may further understand the concept. If a person threw a ball with an initial y-axis component of 30 meter per second and an initial x component of 5 meter per second, what would be the acceleration of it in the independent x-axis and y-axis? Or what are the velocities of it in independent x-axis and y-axis? Now let's talk about it. In in x-axis velocity, it will remain constant. Why it will remain constant? It is because it is not affected by gravity. If you know, the v sub x, or the velocity in x-axis, is 5 meter per second anywhere. You know, it's that everywhere because it's not being affected by any variable. The minimum velocity of a projectile flight is at the top of the peak. And at the top of the projectile's flight, the overall velocity would be 5 meter per second since there is no y-axis component. Now, we have talked about the y-axis velocity. Again, y-axis velocity will be accelerated by gravity. Now, in this particular example, y-axis always has an acceleration due to gravity of 10 meter per second squared down, or 9.8 meter per second squared down. Now, this slows the velocity down on the way up and this speeds the velocity up on the way down. As you can see, the arrow that pertains to the y-axis from the left is bigger on the leftmost side, and as it goes into its y-axis, what happens to the arrow is that it diminished. It's going a little bit shorter than before. Again, it is because of the influence of gravity. Now, mind you, at the center of it, the velocity in y-axis is already 0 meter per second. And as it goes down, it goes back 30 meter per second as the velocity up on the way down. Now, at the top of the flight, the y-axis component of velocity is 0 meter per second. And when the object comes back to the level thrown, the y-axis component of velocity has the same magnitude but opposite direction. The starting y-axis was 30 meter per second up, while the ending y-axis is 30 meter per second down. You would know later as we solve that the positive and negative values of it will tell us if the velocity is going up or going down. A projectile would have minimum speed at the bottom of its flight. The x-axis velocity would be the same, but it would have the largest y-axis component. Therefore, if we will summarize that one, having the horizontal component and vertical components, on horizontal component, the magnitude is constant as well as the direction is constant. While in vertical component or y-axis component, the magnitude changes and the direction changes. With all of these explanation, we think that we can answer this brain twister. You throw a football horizontally and drop a football from the same height and at the same time. Question: which will hit the ground first? It is very basic that all of them will reach the ground at the same time, or all of it will reach the ground at the same moment. Moving on, there are three types of projectile: the horizontal projectile, which the angle is equivalent to 0, the vertical projectile, which is the angle is equivalent to 90 degrees, and the inclined projectile depends upon the inclined object, the angle of the inclined object. Generally, we could have two cases in projectiles. The first case is the projectile thrown horizontally. When a horizontal projectile motion math problem starts with an object in the air beginning with only horizontal velocity, these problems often start with an object rolled off a height, being thrown horizontally, or dropped by something moving horizontally. When you have encountered those particular problem, you need to create a separate X and Y givens list. To understand more, we have here examples for case number 1. So these are being thrown horizontally as being shown. The second case example are these, which is the projectile shown at upward angle. Now, mind you, compared to the projectile thrown horizontally, the object does not came from the air. The object came from the ground, creating a shape of a parabola or trajectory. Now, if you will consider all the angles of it, the longest or the furthest down ridge considering the angle would be 45 degrees, as shown on this GIF. Now, these equations might help you in solving projectile motion. So we have there the components, which are the acceleration, the velocity, and the displacement for horizontal and vertical. For the horizontal acceleration, that is equivalent to 0, as well as the vertical acceleration equivalent to 0. Now, for the velocity, you may use the projectile motion equation, which is v sub x is equal to the initial velocity cosine theta. Also, you may use v sub x is equivalent to initial velocity. Now, we have here the velocity in the vertical component. So, v sub y is equivalent to v sub initial velocity in y-axis sine theta. Or you may also use v sub y is equivalent to initial velocity in y-axis plus gravity multiplied to time. Now, in displacement, you may also use the equation displacement is equal to initial velocity or the total velocity in x-axis multiplied to time. In the vertical, you may use d sub y is equivalent to initial velocity in y-axis multiplied to time plus 1/2 multiplied to gravity multiplied to time squared. Also, you may use this equation. 2 value of the gravity multiplied to the total displacement in y-axis is equal to the initial velocity in y-axis or the total velocity in y-axis squared minus the initial velocity in y-axis squared. So please do not forget all of these equations as this will become very useful in solving projectile motion. I believe you're now ready to solve projectile motion.